if you have more than two vectors acting at a point, you have more than two vectors, 3, 4, 5, and so forth, acting at a point, and you wish to sum them up to get their resultant vector, how do you go about it? That is what we want to do. In this example, we have 5 forces, 5 vectors acting at a point, and we are asked to calculate the resultant of these 5 forces. These 5 forces are coplanar forces. They are all on this plane of the board. We are asked to find or calculate the resultant of these 5 forces. To do that, we employ or make use of the idea of resolution of vector. Resolution of vector. That is, each of these vectors, we are going to resolve them into their x component and their y component. At the end of the day, we now sum all the x components because they will be facing the same direction, or they will be parallel facing opposite direction, and sum all the y components. At the end of the day, we are left with just two vectors, the x component vector and the y component, which is just perpendicular. So therefore, we cannot conclude by using Pythagoras theorem to get the magnitude of the resultant vector, because the x component vector and the y component vector are perpendicular, and we will not also use trigonometry ratio to get the direction of the resultant vector. Now, to resolve each of these vectors into their x component, we make use of this formula. If you have a force which is represented by F, a vector, to resolve it into its x component, which we shall denote with F subscript s, is given as F cos theta. And to resolve it into the y component, which is denoted Fy, is given as F sine theta. So those are the formula for resolving a vector into its x component and its y component. Now we want to resolve these 5 forces. To do that into its x component and y component. To do that, I will employ a table. I will place them in a table so that we will resolve them individually. Now in this table, we start with forces. Now we are starting with first force. The first force is 10 Newton. And the second force is 12 Newton. The third force is 20 Newton. The fourth force is 16 Newton. And the fifth force is 15 Newton. Now, don't forget, to sum these vectors up, we are making use of the idea of resolution of vectors, and that is, we are resolving them into their x component and their y component. If you can see, you are seeing theta here. Now the theta is the angle at which s is inclined to the s axis. Now there are two ways we go about in getting our angle. There are two ways we are going to go about in getting our angle theta, and for that reason I am going to solve this example twice because of this angle, not because of the method. The method is resolution of vector. So there are two ways you go about getting theta. So when you now use these two methods, you will not choose what method you prefer. Now to resolve each of these vector into its x component and y component, I'll quickly put it on a tabular form. Tabular form starts with forces we have in the question. In this question we have 5. Now the first force is 10 Newton. Now the second force is 12 Newton. The third force is 20 Newton. Fourth force is 16 Newton. And the fifth force is 15 Newton. Now this theta, the first method we want to use is theta is angle. Theta makes with S axis. So for this first method I want to use, theta is the angle the vector is making with the s-axis, especially the s-axis closest to the vector. Now, if you look at this vector, 12 Newton, or this force, you will see is making an angle to this x-axis, which is 50 degrees. So that is what we are saying here. The angle a vector is making with the s-axis. But let's start with 10 Newton. What angle is 10 Newton making with the s-axis? If you look at it very well, 10 Newton is already lying on the s-axis. So the angle is making with the s-axis is 0 degree. Now, we now move to 12 Newton. What angle is it making with the s-axis closest to it? It is 50 degrees. Now 20, which is the next vector, the next force, is closer to this horizontal axis. So we are not checking at the angle from this other s-axis. Because it's closer to this s-axis, you are not saying what angle is this force making with this other s-axis. Now the angle is making with the s-axis is what? 40 degrees. Now move to the next vector, which is 16 Newton. 16 Newton is in between these two s-axis, the positive s-axis and the negative axis. And the angle is making with this is 90. And the angle is making with this other negative s-axis is still 90. It's in between. So whichever way you want to choose is correct. 90 degrees. Now, the last force is 15 Newton. What angle is it making with or inclined to the positive s-axis? Because it's close to this s-axis. What angle is this force making with this s-axis? Now, values are not given. The angle here is not given. But because you know from year to year is 90 degrees. This whole play angle is 90 degrees. The angles in between 16 Newton and 10 Newton is 90 degrees. And only this part is 30 degrees. So the leftover angle here will definitely be what? 60 degrees, which is 90 minus 60. To now get the angle 15 Newton is making with this positive s-axis. So 60 degrees. Mind you, like I said, we are still going to solve this. We do now have another method of choosing our angle. So that is how we go about in getting our angle. You look at your vector, your force, the angle is making to the S horizontal axis. Now, in this table, we want to start resolving each of these forces into its S component. So we'll create a table for the S components, which I will call denote as Fs, and Y components, which I will denote as F subscript Y. Now the formula once again is here. So it will now be, because we are starting with this force, F will be 10 cos our angle is 0 degree. Now for the next force, for that same force, let's do the Y component, which will be the force, which is F, which is 10 sine 0. While the next force is 12 Newton. So it will be 12 cos, the angle is 50. And the next one is, for the Y component of this force, it will be 12 sine 50. Now quickly do the others, which is 20 cos 40 and 20 sine 40. This is 16 cos 90, and this is 16 sine 90. The last one is 15 cos 60 and 15 sine 60. Now, because of the method we are making use of, we have to be careful. We have to look at something. When you are resolving a vector into its S and Y component, now these vectors can become negative based on where they find their self. For example, if you have something of this nature, you also have this kind of vector F. To resolve it, if you resolve it, that means you project it, this will become Fs. Now if you project this, this will become Fy. Now on this coordinates, this axis is the positive S axis, and this axis is the negative S axis. While the Y axis, here is the negative Y axis, and here is the positive Y axis. So when you now resolve a vector into its S and Y component based on this method we are using, it can find itself on a negative or positive axis, like this one here, something of this nature. If you project it to the S axis, now if you project it to the S axis, its S component is negative, and if you check it on its Y component is positive. So in this method, you are going to pay attention to that, and you are going to add that to your table. Let's quickly add that to our table. So let's take a good look. Now the first vector is already on the positive S axis. It's already on the positive s axis. So its s component will still be what? Positive. Now, if you are to resolve this into s and y components, it will not have y component because it's already on the s axis. So you don't even know whether it is negative or positive. But we know that because it's sleeping on the s axis, its s component is 0. And at the end of the day, when I give the answer of this, you will see that it is what? 0. So I'm not going to put a sign. Now let's go to the next vector. The next vector is 12. This is fx, this is fy. If you look at this s component, the axis it is on. It is what? Positive. So they still remain positive. If you look at the y component, it's still on the positive y axis. So they still remain positive. Now let's go to the next one, which is 20 Newton. If you project it to the s axis to get this s component, which is fs, and fy. If you look at this s component, it is on the negative s axis. So its s component, because it's on the negative s axis, it must carry a negative sign. For that reason, we are going to add minus to this. We are adding minus because when you resolve this force into its s and y component, its s component is on the negative s axis. It is the method we are using. You have to be careful. You have to look on the axis the components are located. If they are found negative with the quadrants or the axis, if they are negative, you have to put on the sign. Now if you look at the y component, it is still on the y axis, positive y axis. So we are going to leave here as positive. Now, for the next vector, which is this 16 Newton. The next vector, which is 16 Newton, something of this 16 Newton. Now, if you project this to the s axis, it's already where it is projected. Now, its s axis doesn't have s components. It's just lying on the y axis. It doesn't have s components. It's just lying on the s axis. So we don't really know whether it is negative or positive. At the end of the day, you will now see that the s component of this force 16 Newton will give us 0 because you don't have a s component. It's lying on the y axis. Now what about its y component? Its y component, if you look at where it is on the negative part of the y axis. It is on the negative part of the y axis. So you add a negative sign here. Now for the last vector, which is 15 Newton, we project this to resolve it into its s component. Here will be fy and here will be fs. Now if you look at this s component of this force, it is lying on the positive s axis, so we leave here as positive. While if you look at here, it is lying on the negative y axis. So this y component will definitely carry a negative sign. So that is the method we are using. You will see the way we trace out the angle. We brought out the x comp and y component, and because of this method you have to signify the negative and the positive part of it, the one that is falling on the s negative axis and the positive axis. Now the next method I will later use, you will not bother in trying to locate whether it's falling on the x axis and y axis. Once you get your angle, it will give you a correct answer. But now let us continue with this. Okay, I've quickly, without wasting time, I quickly gave the values for this expression, for individual expression. 10 cos 0, which is 10, 10 sin 0, which is 0, this for this, this for this, this for this. So that has been done quickly. Now then sum all these to get this, because these are the s component vector. When we resolve it, recall the s component vector, as is their s component vector, definitely they will be parallel, either facing the same direction or facing opposite direction. So we just sum them for that reason to get this single s component vector, which I call summation f subscript s. The same thing goes for this. All these are the y component vectors of all these vectors. They are in the same axis. They are parallel, and they are either facing the same direction or opposite direction. So we just quickly sum them up to get one single y component vector, which I call summation f subscript y, which gave me this. So we are just left with two vectors. We are just left with two vectors, and want to sum it up so that we can get the magnitude of the resultant vector. But to do that, we have to represent this on a diagram so that we can get a clear picture of how to sum it up and how to get its angle correctly. Now if you look at this, it's on the s-axis because it's a s component vector and it is positive. Definitely it will be something of this nature. It will be here, because it's on the s component vector and it is positive, this part. So we represent this as 9.89 Newton. Now if you look the other one, it's on the y axis, a y component vector. So and it is negative. So it will be on this side. It will be on this side. So we want to make it small. So that will be minus 6.96. Minus 6.96. While the other one was 9.89. So you have to bring this and place them in a diagram so that you'll be able to get your resultant vector correctly and its direction. Don't just place these two vectors anyway. Now recall, the s component vector and the y component vector are always perpendicular, and that is what we are seeing here. They are perpendicular to each other, and since they are perpendicular to each other, if you want to sum the two vectors up quickly, you just employ Pythagoras theorem. Definitely, if you place this here, you take the initial point of minus 6.9 Newton and place it here. It will be something of this nature. Then you will now join it together. When you join these together, this will be your resultant vector, which I denote as r. Good. Here and here is equal. So here is the 6.96. The minus is to tell you the direction. Now, as earlier said, if you want to get the direction, it will be theta, the angle. And it will be the angle the resultant vector is making with the s-axis. So this resultant vector here is making an angle with this s-axis here, theta. So that we are going to go ahead to solve for theta 2. Now this is it forms a right angle triangle. So we just use Pythagoras theorem, arrow square is equals to 9.89 square plus minus 6.96 square. Now arrow will then be, we are looking for arrow, not arrow square. So you square root everything. The square goes to the other side and becomes square root. Bracket 9.89 square plus minus 6.96 square. That is that. Now if you do everything correctly, if you press this minus 6.96 square to be a positive answer, this will be a positive answer. Sum them all and take the square root. You are going to arrive at arrow is equal to 12.09 to 2 decimal place Newton. This is the magnitude of the resultant vector. Why we choose to end with this calculation is because we are just left with two vectors, the y component vector and the s component vector, and they were perpendicular. And we have said earlier that if two vectors are perpendicular, to get their resultant vector, you use the rule, and it has formed a right angle triangle which led us toward Pythagoras theorem. So this is the magnitude of the resultant vector. Now we have cut out or drawn out the illustration of the s component vector and the y component vector along with the angle. You should do it correctly so that you will be able to get your direction. Now let's consider we are looking for theta to give us the direction of the resultant vector. So with respect to the angle, look at what you already have. Look at what you already have. We already have this side. This side is parallel and equal to this side when you join it. So we also have this side. So with respect to this angle, this side is the opposite side. And with respect to this angle, this side is the what? Adjacent side. Because we have these two sides, the trigonometry ratio that we are going to employ, because we have these two variables, these two sides, is tan theta, which is opposite over adjacent. Because we have opposite and adjacent, and we are looking for what? Theta. So the negative sign is just to tell you the direction of this vector. But 6.96 is the what? Value. So take 6.96. And the adjacent side is 9.89. Be careful about the negative sign. It just gives you the direction. When you are now on the journey to get your theta, just take in the values, only the values. Now you take the arctan or both sides, arctan or 6.96 over 9.89. Now when you do that, theta will be equals to 35.1 degree. 35.1 degree. So this gives us the direction. But if you want to move further and you want to put it in bearing form, then we have to use the 4 cardinal points, which is west, east, south, and north. Now the resultant vector is in between south and east. So we have to call south before east. So the angle between south and east will be 90 minus 90 minus 35.1. 90 minus 35.1. Which will give us 64.9. 64.9. So the answer, the direction is south 64.9 degree east. Because you are always measuring the angle either from the south to the east, south to the west, north to the east, north to the west. But this angle was from year to year. So we now decided to get the angle from year to year. That is the direction. If you still want to use 360 degree bearing direction, you are going to measure your angle from the positive S direction, then you move round. This all round is angle at a point, so which is 360 degree. So it will now be 360 degree minus 35.1 degree. Your answer will also give you a direction of the resultant vector. It's just different way in which you talk about direction. But theta, which is the angle in between, was the first direction. But if we were to use north and south, this is the direction. And if you want to use 360 degree bearing, you can still go ahead to do that. So we have ended this topic. A journey of adding 5 coplanar forces. The magnitude was this and the direction was this. Now, like I said when we started, I said it is still the same method, which is resolution of vector, but it's just only how we are going to pick our angle. That is what I want to proceed now to do. I want to choose our angle differently, but you will still see that we will still arrive at the same answer. So you will now choose your method or ways in which you will be choosing your angle. Because what we are doing is, you look at the vector, the angle is always making with the x-axis. Now the next method we want to use is the angle the vector is making with only the positive x-axis. Not just any x-axis, but the positive x-axis. The positive x-axis. So on the second method is how we go about choosing our angle. So instead of angle theta makes with x-axis, it will now be angle theta makes with positive x-axis. Angle theta makes with positive x-axis. So this is another way of choosing your angle. So let's start with tenuity. This method of choosing your angle is like moving anti-clockwise. It's like 360 degree bearing. You start from the positive x direction, then you move to where your vector is and you stop. The amount of angle, you pick it. So the first vector, the first force is tenuity. It's already lying on that positive x-axis. So the angle it makes with the positive x-axis is definitely what? 0. Now, for the second vector, which is 12 Newton, the angle it is making with the positive x-axis, you are counting your angle from this positive x-axis, you move till you get to this vector, which is 50 degree. 50 degree. Now the next vector is 20 Newton. So you will start your measuring your angle from the positive x-axis and you move till you get to this point. That is from here. So yeah, that's how we are measuring our angle now. So what is the angle from this positive x-axis till you get to this vector? Definitely, this is a straight line. So the angle on it is angle on a straight line, which is 180. The full angle on this straight line is 180. But you are just removing this part. So only this part will be 180 minus 40. 180 minus 40, which will give us 140. Now somebody would have could have go about and add this angle to this angle to this angle, which will now give us the angle. But you don't have the value of this angle, you don't have the value of this angle. That's why we have to follow that procedure. When I say angle on a straight line is 180 minus 40, which will give us the leftover angle we are looking for, this part. So that is that. Now the next vector of course is 16 Newton. So we are going to measure our angle from this part. We will move right.